All right, so this is a very important numerical for students who will give the state board or the CBSE exam, or for that matter, any exam across the globe. The topic is uh, radioactivity, and this is a case study we will be attempting today. It's a very good case study, which you must know as a general knowledge also. While not everybody will know the physics of it, but you must know as a general knowledge that the radioactivity is very much part of living organisms. And if you read this question, it says that the normal activity. So when the word normal activity is mentioned, it means, it says the normal activity of living carbon containing matter, which is us, human beings or animals or anything you see which is alive, living, has carbon 14 inside it. If you see this question, it says that living carbon containing matter. So we have carbon 12 and carbon 14 also. Carbon 14 is the one which is the focus of this question, and it is radioactive in nature. Carbon 12 is not radioactive in nature. And carbon 14 is available in atmosphere also. We also absorb carbon 14 through the food we eat. So if you eat something, you will absorb carbon 14. If you die, then you stop absorbing carbon, and the carbon comes out of your body, the carbon 14. When I say carbon now, henceforth it will mean carbon 14. I hope this is clear, that living organisms absorb carbon 14 when they eat food. When they die, they stop absorbing the carbon 14, and the carbon 14 then decays from their body. If you read this question, there is also a mention that the half life of carbon 14 is 5730. So after every 5730 years, the number of carbon 14 nuclei in your body goes down to half. We will study all of this, but I'm just giving you a background so that you're clear on the question this is. This is a general knowledge question also, and is covered in the topic of something called as carbon dating. Carbon dating is a technique used by radioactive engineers to, or nuclear engineers, to ascertain the date of dead or very old living material, maybe dinosaurs, or some period before AD, after AD, or BC. All right, so you must know about this as a general knowledge, and let's now study the basic concepts which you must know to be able to solve. A lot of students have confusion in the topic of radioactivity, and I will remove those doubts also through small explanations, and then we will solve this problem. I hope the problem is clear. The problem statement is that living organisms have carbon 14, and when they die, the the traces of carbon 14 reduce to half every 5730 years. Also, there is mention of the word 15 decays per second and 9 decays per second, which I will explain you. These words actually refer to something called as activity. If you're studying the chapter of radioactivity, this is activity is bound to come. So we will study about activity also, right? And I will explain you what it is. The activity goes down actually. All right. So to start with, understand that the every living organism. Okay. So if you are living, you absorb carbon. Once you die, right? So you start reverting back to nitrogen 14. Okay. This is called as a daughter. Okay. Sorry, the mother nuclei. So this is your mother nuclei, which is disintegrating, decaying or disintegrating, one and the same thing. All right, and now you're like dead, right? So and this is your electron which gets released, and then there is a anti-neutrino also gets released. So this equation is what we are studying, and it says that after every 5730 years, you reduce to half. So if you start with 100 nuclei of carbon 14 in your body, after 5730 years, you will have 50 left here. Okay, you will have 50 carbon 14s left, because this particular age is also known as half life. Half life. The amount of time it takes for the nuclei number to become half of their initial value. So the mother nuclei started with 100 and it became 50. This is the way you need to look at the carbon dating. This is one concept, which is equation. So memorize this equation. Useful information. It's a standard equation that everybody should know as a general knowledge. The second thing you must know is about half life. Okay. Now, half life, I have already explained you what is half life. Another expression that you see repeatedly in these questions is lambda is equal to 0.693 divided by t half life, which is this is t half life, right? Now, lambda is called as a decay constant. It's a constant, remember, it's a decay constant. Okay, and I'll tell you what does it mean. It actually implies the probability of decay. Okay, I hope you understand what is the meaning of the word probability. So if you have a nucleus, what is the probability it will decay? If the probability is very high, it will decay. The half life is going to be smaller. If the half life is large, then we're saying the probability of decay is low. Okay, so this is the way they're linked to each other. A lot of questions come on this topic. The third thing you must be aware of in this topic is the concept of, which you see pretty repeatedly, is the number of uh, mother nucleus, which in this case is carbon. If you see the equation, I use the terminology. So carbon 14, for example, you started with 100 and you want to calculate at any time what is the number of carbon 14 left in the body, right? So what you do is, this is the starting number, which was 100, and then what you do is you write it as e raised to power minus lambda t. Lambda is what we have studied, the probability of decay. T refers to the time elapsed. Now you could find this in 100 years. How many? I have told you that yes, the number of nucleus left in 5,730 years is 50%, right? But what if you want to find out in 100 years? What if you want to find out this in 50 years? Use this formula. Okay, this gives you the number of parent nuclei, the mother nuclei, count after some time has elapsed. This is very important to understand. And of course, since the word mother has come in, remember that nitrogen therefore is called as a daughter nucleus. Daughter nuclei. All right. And we can find the number of daughter nuclei also. The only difference is you could probably change the formula to n is equal to n naught 1 minus e raised to power minus lambda t. Right. So if you want to find out the number of nitrogens which are getting created, use this formula. If you want to find the number of parent which is left after time t, please use this particular formula, which is formula number 3. Right. So this is all about the count of nucleus. Okay. Count of nuclei. So far, we have not even spoken about the word activity. So if you go back to the question, it talks about this particular thing, right? If you notice, it talks about 15 decays, which is what I said I will cover later. 15 decays per minute, sorry, for every gram of carbon, and then it talks about, I think it talks about 9 as the new decays per minute, right? So the activity when the start is this much, and the activity begins to drop, right? It says that the activity begins to drop. Okay, and so what are you supposed to find out? Yeah, so the new activity is 9 decay per minute. This is what you need to be worried about. Okay, so I will now explain you what does it mean. Okay, what it means is the activity actually is the number of disintegrations per unit time. So it is represented as, it is some kind of speed. Okay, so the activity of the parent, which is carbon, which is what we are worried about, and carbon dating is worried about that only, is measured as the starting activity when the organism dies. That's a starting activity, and then e raised to power minus lambda t. This is the activity which is 15 decays per minute, and this is 9 decays per minute. Okay, this is the activity after some time. Okay, and what is that you're going to find out through this? So if you know the activity later in the time, you know the initial activity when it starts disintegrating, you can find out the time elapsed from the time of death. So if you talk about the graph, it is exponential in nature. This is the way it looks. So this is your activity, starting activity, which is a, okay, a naught, and then of course the activity reduces, by the way, as the time progresses, and then obviously at certain point, the in this case the activity started with 15 and it became 9. So you can see the rate at which it reduces is not linear. It is not like this, okay, straight. No, it is exponential. For this question you have to focus on formula number 4, because the question gives you the value of what? It gives you the value of activity. It doesn't give you the number of nucleus of carbon 14. So you will emphasize immediately when you study this, just worry about formula number 4 if you see decays per minute type of questions. Okay, now let's solve this question with this knowledge we have acquired from the above theory. Straightforward, you know the decays are 15. All right, now it is per minute. Now you can do anything, right, but keep the units as same. Is equal to 9 e raised to power. Now what is lambda? I told you lambda can be calculated as 0.693, and remember this negative sign, it tells you that the slope is negative always, right, and it is decreasing, disintegrating. The parent nuclei, which is carbon, is reducing. The half life 5730. It is in years, converted to days, and then converted to minutes. Okay, so this is years, now this is hours, and this is minutes. So use this is probability constant, which you will use in the formula here. So you used the knowledge of half-life and found the decay constant, because lambda is equal to 0.693 t1 by 2. Now start putting the value e raised to power. Put the lambda here, uh, which is what we just calculated from this expression. Put the value here, point e raised to power, whatever you calculate, just calculate this, calculate this whole thing. All right, and substitute here and put the value and into t. Okay, I have converted everything into. Now lambda is also known to you. You can take log of both the sides. Log of 15 is equal to log of 9. If you want to take natural log, you can take natural log also, and solve this question. Okay. By the way, lambda can also be written as log of 2 divided by 5730, because this is natural log. The value of log 2 is 0.693. Natural log 2, natural log is 0.693. All right, so you can solve this and you can take natural log or whatever you want to take. Ensure that in these questions you have complete clarity on log table. Do not leave your classrooms without learning the log table. If you don't know log table, you will land up in trouble in these questions. So it is very important that you learn the log table for these questions. Understand both the base 10 and natural log to be able to solve this question. So if you find the value of t from this particular approach, you will find t. That is a time which has elapsed and can tell you the age of the specimen, right? So specimen means what? A specimen of some living organism which died. Okay, and you can then estimate the age, how long it took it to, when was it alive last. So if it was, for example, whatever the answer comes, it was, the answer for hypothetically is 150 years. So this particular organism died 150 years back. That is carbon dating for you. So please attempt some numericals where you use each of these formulas. Where this is an important one, the association between decay constant and half-life. This is an important one, the number of parent nucleus, and this is the activity of the parent nucleus again. And this is the initial activity, which is given 15 decays per minute. I hope this is clear in your mind. Some sense has prevailed and you will be easily able to solve the questions. Thank you very much for your time and wait for my next video.